Okay, ladies and gentlemen, welcome to your SAT Prep Math Group for Week 4. Those of you that are watching this video are actually sophomores, but we've switched you over to the junior material so that you will have material that is more accurately aligned to what you are doing in your pre-AP Algebra 2 class. So a vast majority of you should be pre-AP Algebra 2 students. Either way, I still need you to make sure that you print your name legibly at the top of the paper, first and last name please, and that you circle your teacher's name and the class that you are in. Now if you're in more than one, feel free to circle more than one. Okay, so this week's material is Systems of Linear Equations, Substitution and Elimination. So we're going to carry out two examples here on the first screen, and then we'll change it over and we'll do the next two. So example 1 says, if xy is the solution to the system of equations shown below, what is the value of 3x plus 2y? So once again, this is the SAT. We have here a math problem that we should all know how to do from algebra, but then we have to take that solution and do something else with it. So hopefully everyone in here is well versed in telling that this problem is set up for substitution. We have y equals and then an expression in terms of x. So every single one of us should want to instinctively take negative 2x plus 7 and replace the y in the first equation with that value. So that would give us the equation 5x minus 3 times negative 2x plus 7 equals 23. The point of that being that by replacing the y in the first equation, we have taken an equation that cannot be solved, an equation that has two variables, and turned it into an equation that can be solved because it only has one variable. So now we're going to solve that equation for x. The first step in that process would be to distribute the negative 3 through the parentheses. So negative 3 times negative 2, negative 3 times 7. And that would give us 5x plus 6x minus 21 equals 23. Then we would combine like terms. 5x plus 6x is 11x plus 21 equals 23. At which point this is a two-step equation. We would add 21 because I've got a sign error there. This should say minus 21. And we would be adding 21 to each side. There we go, all better. So add 21 to each side would give us 11x equals 44, which means we would divide each side by 11, and we would get x equals 4. Now once we know that x equals 4, we should then take that and plug it back into negative 2x plus 7, the second equation. We should be plugging in 4 for x and then solving for y. So y is negative 8 plus 7. Negative 2 times 4 is negative 8. Add 7 means y is negative 1. Now if this were an algebra problem, we would be done, but this is an SAT problem. So then what we do is we go in here and we say, well, we need the value of 3x plus 2y. And we plug in x equals 4 and y equals negative 1, and we simplify that down to a single number. 12 plus negative 2 means that our final answer is 10. So instead of giving the answers in ordered pair, we take x and y and we evaluate whatever expression the SAT asks us about. Let's do another one. If xy is a solution to the system of equations shown below, what is the value of x divided by y? Well, I look at this system and right away I worry about those fractions. So what I would do is I would start off by getting rid of the fractions. So the first equation, to get rid of the fractions, I would multiply by the common denominator, which would be 4. As it turns out, coincidentally, I would end up doing the same thing to the second equation because it too has a common denominator of 4. It only has one fraction, and that fraction has a denominator of 4. So I would do that first, and the main reason I would do that is to get rid of the fractions. See, that turns the system into x plus 2y equals 28, and 4x minus y equals 40. Those, quite frankly, are much better numbers to work with in any sort of system of equations problem than fractions. So then, once I've gotten rid of the fractions, I would evaluate this and look at it, and I would say, well, if I multiply the second equation by negative 2, that would turn the second equation into negative 8x plus, I'm sorry, by 2, not negative 2. Multiply it by 2, not negative 2. My mistake. That would turn that expression into 8x minus 2y. Making all sorts of mistakes this afternoon. Minus 2y equals 40. And the reason I want that is that when I compare that to the first equation, I now have a variable that will be eliminated if I add these equations together. So I add these equations together, and that gives me 9x equals 108, because I didn't multiply my 40 by 2, because I'm for some reason struggling today. We all have good and bad days, so that's wonderful. Okay, so 28 plus 80, which was 40 times 2. Remember, we multiply everything by 2. Don't pull a Mr. Wills and only multiply one side of the equation. And then we add down. 28 plus 80 is 108. That 80 is really bothering me, so I'm going to clean it up and pretend I didn't make that mistake. Okay, anyway, that leaves a one-step equation. We divide both sides of that equation by 9, and we get that x is equal to 12. Then we take that x equals 12, we plug it back into one of the original equations. I'm going to use this one right here, x plus 2y equals 28, to say 12 plus 2y equals 28. And then we solve that equation. So we would subtract 12 from each side, which would give us 2y equals 16. And then we would divide by 2, which would give us y equals 8. Now again, if this were an algebra problem, we'd write the ordered pair 12, 8, and we would be done. But that is not what's happening here. What's happening here is that we need to take those two and we need to plug them in to the expression x over y. That would be 12 over 8. Then we should reduce that fraction. 12 and 8 are both divisible by 4, which gives us a final answer of x equals 3 over 2. So 3 over 2 would be the answer we would be looking for. Now the good news is that questions like this are generally multiple choice questions on the SAT. But again, remember that bad answers on the SAT are the other answers. So if you made a small mistake, one of the answer you came up with would be the answer as the other answer choices, the incorrect answer choices. So that does it for our first two examples. Again, that's solving a system of equations. Example 1 is by substitution. Example 2 involves clearing a fraction and then using elimination. So you have examples of both situations plus how to clear fractions. Example 3 is a little bit different, so let's go and take a look at that. Example 3 is a more conceptual question. It says, for what value of k does the system shown below have no solution? Well, remember that in order for an equation to have a no solution, we need both variables canceling, and we need what's remaining to be a false statement. Okay, so we need the entire left side to cancel out, the x and the y, and then we need what's left to not be a true statement. So our first step here should be to set up the y for elimination, which would involve multiplying the first equation by -2. Now the reason I'm multiplying by -2 is I need this to be -6 so that the y's would cancel out. So when I do that, I'm going to write what's left. I'm sitting at -2x minus 6y equals +8. The second equation is kx plus 6y equals 5. So we already know at this point that if we add these equations together, The y's are definitely going to cancel. But we also need to have, this needs to cancel as well. So most of you are going, okay, get to the point. Well, that means that k must be positive 2. So that this is negative 2x and positive 2x. Now if we do that, if we plugged in a positive 2 for k, we need to check and make sure that that does in fact produce a false statement. Well, that's gone and that's gone. And we look at what's left, which is 0 equals 13. That is a false statement. That means this system now has no solution, which is what we wanted. So we are looking for, our answer is that k must equal 2 in order for that system to have no solution. Okay, it's your turn now. There are 4 problems on the back of this worksheet. Please try those 4 questions. Remember to box your answer, make your work clear and concise. And when you get done, turn it into your proctor. Thank you very much for your time and attention. Have a wonderful week.